In this video, we're going to talk about the altitudes of a triangle. Now, altitude has a lot of real-world applications to it. When you talk about the altitude of a plane, you talk about how high it is off the ground. Um, Altitude truly is the height of any given object. So, to demonstrate what altitude really is of a generic object, what I'm going to do is I'm going to open up here a little picture of Mario. We'll throw them here on our presentation here. Now, when we talk about how tall this picture of Mario is, we're saying how tall he is in relationship to the x-axis here. So what we would do is we would take a look at the highest point on Mario, which would be approximately at point C. And then what we would do with that is we would look at a line that is perpendicular to the x-axis. I think I need to draw in that x-axis here. So we'll draw in a line that goes through points A and B. And I'm going to take a perpendicular. We're going to go perpendicular to C. I'm sorry, it's not perpendicular to C, but it passes through C and it's perpendicular to line AB. That would tell us how tall Mario is that line right there. Now the reason we use that is because that's the shortest distance that C is away from that line. We could take and we could put another point on this line. Oops. Let's get rid of that. And we could put another point out here on the line, and we could draw this segment here. Let's go down to our segment tool and draw a segment from C to D, and we can look at the length of that segment. Right now that segment has a length of 6.14. Now as I move that segment further and further away on that line, you can see that it gets larger and larger. As I move it closer and closer to that perpendicular is where it gets to its smallest point. Right now it is at 4.32, which I think is about as small as it will get. I'm trying to show it to you. There it is, 4.32. Now, as I move it further away, even on the other side of the line, you can see it only gets bigger and bigger. This perpendicular distance, or altitude, if you will, is the shortest distance from that top point to that line. So we use that because it's a consistent measurement for us in all things. So whenever we talk about how tall something is or the altitude of something, it's always in a perpendicular relationship to a given line. So we're going to get rid of all that stuff. And let's talk about it in terms of a triangle now. So I'm going to look for some more options here. We're going to draw in a triangle. Go here, here, and here, creating that full triangle there. Now, so what a altitude will do is it'll travel from a vertex and be perpendicular to the opposite side, giving you the height of the triangle from that perspective. So I'm going to draw in a perpendicular here from A down to BC, from B to AC, and from C to AB. So there's our three altitudes of that triangle. Now we can monkey around with this. We can move this triangle around like we have for the other ones. The centroid stayed within the triangle all the time. The in-center stayed in the triangle the whole time. The circumcenter, if you remember, went outside of it when it was an obtuse triangle, stayed inside it when it's an acute triangle. Well, if I look here, I have an acute triangle. As I move to an obtuse triangle, you can see that it extends to the exterior of the triangle, just like the circumcenter did. And when it's a right triangle, it's on the edge of the triangle. So, like the circumcenter, the altitudes cross at a point that can be inside the triangle, on the triangle, or outside the triangle. This point is called the orthocenter. So let's mark that point on here by using our intersection tool. Look at the intersection between those two lines. So point D is our intersection. Now that orthocenter has a special relationship with the sides of a triangle. So I'm going to pull up a picture that I used earlier on in one of my other videos of a map, and that map includes Indianapolis, Cincinnati, and Louisville. We'll blow it up a little bit. Oh, I think I had the same problem last time. It's a little bit too big. There's a good size. So now, if I wanted to place a center of business in relationship to these three cities, and again, I chose these three cities because Indianapolis and Cincinnati are connected by I-74 or Interstate 74. Cincinnati and Louisville is connected by I-71. And Louisville and Indianapolis are connected by I-65. Those three highways kind of triangulate a little bit here between those three cities. What I would like to do is I'd like to take a look at placing a business so that I am closest to all three highways as possible. Not the same distance like we did for the in-center, but the closest distance to all three highways. And that closest distance is at a perpendicular relationship to each side. So it might not be realistic with the roads that we're looking at, but just location wise, if I wanted to place a distribution center so that I am the closest to I-65, I-74, and I-71, I'd probably look at a location around this area of the states. I believe that's probably in Indiana somewhere, but it is close to that national park that's right here. But this would be the location that would be the closest to all three sides, and that's what the Orthocenter would give us.